Hello, I'm JW. This time we have another item that's been sent in, and this one is from Scott in Canada. But of course the item itself was not made in Canada, it was of course made in China. And it's one of these power cords that's typically used for computers and various other bits of equipment. But as usual, of course, it's certainly not up to the required standard, so let's have a closer look. Now, as well as the lead, we've got a copy here from the listing that this was purchased from, and this item actually came from AliExpress, and here's the picture of the thing, and it does at least seem to match the picture that we've got, so that's fine. But not much in the way of description here, it just basically tells you sort of what the ends are, length 1.2 meters, and suitable for US standard only. And it came from AliExpress, as said there, and so it's just one of these sort of Chinese direct import type of items. Price on the back there, you see, is $1.95, so pretty much as cheap as you can get. So here's the actual thing, and I say this end is just that normal sort of clover leaf or three-prong thing, commonly used for laptop power supplies and similar. And then the other one here just got the usual North American plug with the three prongs, or the two blades, and of course the round one for the earthing connection. Now here's the two ends, this one just with the three pin or three holes there, and you can see inside some sort of goldy coloured metallic contacts. But if you bring in this magnet here, you'll see that it's clearly attracted to the magnet, so it's pretty obvious that they're not going to be brass or copper as you would expect, so that's certainly not good, because clearly it means they're either steel or steel with some kind of plating on the top. And this end is just a normal North American plug. See, that pin is actually slightly bent down out of shape, and we can easily just bend it to whatever shape we want, so not very good. And again with the magnet here, see, it sticks straight on, so pretty obviously that's not what it should be made of. It's probably steel with just a thin coating, or maybe no coating at all. But that round pin certainly is strongly attracted there. The flat pins do not appear to be, so not even consistent with the materials used within the same plug. Now the wire here, as you can see, says made in China, and the PVC, and the side here is indicated as 3 cores, and the size of each is 0.5 square millimeters. Now that's pretty much the smallest sized flex you can get, and that marking is repeated at several places further down. So 0.5 millimeter flex. Now in the UK that would typically be only rated to about 3 amps absolute maximum. It's the sort of thing you might use for a table lamp or something, just say 60 watt bulb or something, it was the old type, and that's pretty much it. Now as this has got this style of plug, it could of course be used for a variety of different things, and while 3 amps is certainly not a massive amount of power, it's quite likely that these things could be rated for more than that. Now if you have a look at that round pin there, you'll see it's not even made of solid metal, it's actually hollow. So if you look at the end there, you can see that there's that sort of 3 pieces have just been folded over, and there's actually a gap between all of them. So this pin is not even solid metal, it's just a thin wall tube with the end simply just folded over to form a sort of a point on the end. And well, we're having a look here, you can see the rating there's 10 amps, 250 volts. Well, it's not going to be rated for 10 amps because clearly that flex is never going to take 10. And of course 250 volts is irrelevant because this plug is not used on that type of system, it's the 120, so not entirely clear what they're doing. But just demonstrate the point of this pin here, just get these pliers, just demonstrate that this is in fact just totally hollow, because if I just crush it down, as you can see, it's just a completely hollow thin wall tube, and it's just simply been folded round, and the ends just simply crimped over there. So it's definitely not of a high quality construction. You see it's very easy to bend there, and so these are fairly small pliers, so look at the wall thickness, see how just thin that actually is. So there you go, it's just some sort of folded over ferrous metal of some kind. Now just do a few basic checks on this. So of course we should have continuity between the 3 here and the 3 over there. So got the meter there, and just connect the black lead to this end. So we'll go for the pin here to start with, and if there is continuity, then of course we should hear that. So let's just poke into the pinholes. So we've got continuity there, and of course not to the others as you would want. and this other one here. So again, that's fine, and not in there. And then, of course, lastly, the now flattened earth pin. But it appears there's no continuity on the earth whatsoever. And bearing in mind I have flattened this earth pin, but it's not actually been removed from the housing at all, so any wire that was in there should still be connected, but pretty obviously it is not. Now the question is that just because it's moved slightly, because it was a bit loose before. But no, there's absolutely nothing in there, so that's clearly a fail straight away. Now I'll just measure the actual resistance of these wires. Unfortunately only two of them, because of course the earth one appears not to be connected. So we've got the clips here, so we'll just go for the one on this side first of all. And let's press the other lead in here. You can see the display there on the other camera. And of course this should be ideally as low as possible. But unfortunately it's not very low at all, so we'll have to move up to the other range. Okay, so measuring there 1.057 ohms, which let's just say is excessive for a lead of this length. Bearing in mind this is just over a metre in length. And let's just try the other conductor, which theoretically should be identical. Okay, so that's 1.051 ohms. So basically just looking at just over 1 ohm for the two conductors there. And of course the earth one isn't connected, so no point in testing that. So whatever's inside here either isn't copper, or it's considerably smaller than 0.5, or both of those things, but certainly in either case 1 ohm or just over is far too high for basically just over a metre length of the wire, even accounting for the slightly higher resistance of the end connectors. And for comparison, I've got here length of flex here, and this is also 0.5 square millimetres. This is actually solid copper, as it should be, and it's the same length as the black one that we had here. So if this is solid copper 0.5, it should measure exactly the same as this. So let's get the testing things in again and see how this looks. Now all three of these should be the same, so let's go for the brown one. Just clip onto the brown one there, and we'll just clip onto the brown one over here. Now straight away you can see there that the reading we're getting is actually 0.04 ohms, so tiny fraction of what we had before. Just move up to the other scale there. So looking at about 46.5 milliohms. So a microscopic fraction of the 1 plus ohm that we had previously. And we can actually measure the others as well, which should also, of course, be pretty much the same. So that's what, about 49 milliohms for that one. If we go for the blue. That's coming out at sort of 46.5 or so. So all pretty much in the same sort of area. And bearing in mind this is sort of 46 milliohms, this is over 1000 milliohms, so orders of magnitude greater. And so even accounting for the fact that this may have steel ends, that's still absolutely colossal, because bearing in mind the steel bit is only the piece at the plug end. The flex here, of course, is joined straight onto that. The same with the contacts there. So there's things desperately wrong with this lead. First problem, of course, is that earth wire is not actually connected, and so though I've flattened the pin there, it's still fully connected into the housing, so that itself should not have caused it to disconnect. More likely it was never connected in the first place. Of course, the resistance is massive, over 1 ohm, or compared to 50 milliohms for this white piece. And this is definitely 0.5 square millimetres. This claims to be 0.5 square millimetres. And if we place the two things together, so there's the end there. Now we just extend along to the other end, and I see precisely the same length. So you expect them to be at least in the realms of similarity, but clearly 50 and over 1000 are very far apart. Now, of course, the only sensible thing to do with this power lead is to now take it outside and shove a load of current through there and see how hot it gets and how long it takes before it sets on fire. Now, here we are outside, and unfortunately I had a load of problems with this, mainly due to the ridiculously poor quality of the whole thing. Now, originally I was just going to put a sort of a link in the end where the socket is and just sort of short those two together. And unfortunately it was impossible to get any kind of reliable connection there, so I ended up having to actually cut the plug off and then just twist those wires together and solder them, making a short circuit. And a bit further along the lead here, we'll see I've just attached the temperature probe there, just a bit of tape to secure it to the middle of it. And then at this end, just got the plug and just soldered two wires directly onto the two pins there. They already had holes in. Now the earth one is actually missing because it basically just fell out of there. And if you actually look inside the hole, there's this microscopic little tiny piece of material in there where the earth pin used to connect. But basically there was no actual continuity on it anyway, so clearly that was defective from the start. Now, unfortunately, this particular setup didn't work at all, because as soon as the power was applied, even at sort of sub 1 amp, it basically went open circuit due to some fault, probably in the plug at the end there. So that was a complete fail, and it just simply didn't work. So I had to completely get rid of that. And hence there we're going to move on to the next arrangement. And this is basically what we've ended up with. Now, we've got the lead there, and I've had to actually cut the plug off as well. So I've essentially got the lead itself with no connectors on the end, and I've just connected one into the two wires there. So I've got the blue wire at the bottom there and the brown one at the top. And for monitoring, still got that temperature probe just taped to the flex there about halfway along, and temperature displayed on the meter there. It's currently about 10 centigrade, and the current will be displayed on that clamp meter. Also, that's currently 0 until we switch that on. So I'll just switch on the power there, and see we're starting out with a kind of about 2 amps or so, and say temperature there about 10 centigrade. Now this is outside, and it's March, so it's fairly cold, so that's entirely what you would expect. Now, although the resistance of this lead measured is rather high in the sort of 1 ohm range, because of the despicable way it actually just fell apart at the ends, we've actually now got all 3 of the conductors basically twisted together and wired up in parallel. So although the resistance was measured about 1 ohm, it's actually going to be about 1/3 of an ohm now, which is obviously considerably better in terms of conductivity. So it may well be that the current doesn't actually do a great deal until we turn it up to a much higher level. So around the 5 amps or so mark there, or just sort of 5.3 or so. And the temperature has increased, but only by 1 degree, so 11 centigrade there. And it's gone up to 12. So we'll leave this going for a few minutes and see what happens. Well, several minutes have passed, and we're only up to 17 or 18 there, so pretty much nothing's happening. So let's crank up the current to a more sensible 10 amps. And bearing in mind that's what this thing claimed to be rated to on the plug, so 10 amps there. So let's see what happens once we get to 10. Well, the temperature's certainly rising there, up to coming towards 30, and the current's still holding just over 10 amps there. Now, it's been on at 10 amps for a number of minutes now, and the temperature's around 60 centigrade, and the wire has visibly softened a bit. It's now laying almost flat on the surface there. Of course, the plastic or whatever it's made of sort of deforms and sort of flattens out. Now, the inner wires on this were certainly not copper. They were copper coloured, but they were probably aluminium, as they were extremely difficult to actually bend into shape, and they were certainly difficult to solder to anything. And in this case I've just had to use those screw connectors because soldering to them was proving exceptionally difficult. And the actual insulation inside had a rather bizarre selection of colours. It was basically green, which was for the earth which wasn't even connected, and then both of the other two were actually blue in colour, so that certainly wasn't any kind of known standard. And the inner insulation seemed to be some kind of rubber material, whereas the outside plaque covering seems to be PVC or some kind of variant of, so a various mixture of materials is being used in this. Now we're still at the 10 amps there, and this has been going, say, for 5 minutes or more now, and the temperature seems to have stabilised around the sort of 69-70 centigrade mark, which is theoretically the limit for PVC type installation. Generally it's either rated to 60 or 70, but bearing in mind we've got all 3 cores in parallel there, so this is actually considerably better than it would be if it was used in a real situation. But in any case, this has been going on for too long, so it's now time to crank the current far in excess of 10 amps and destroy this thing regardless of whether it's sensible or not. So we'll just turn up the current, just passing 15 amps there, and the temperature just above 70 at the moment. But I think we'll just continue on anyway, because might as well go up to, say, 20 amps, and that will certainly cause rapid overheating and hopefully destruction. So we're just approaching the 20 there, and you can see the cable in the background is actually now sagging down due to the excessive heat inside, and the temperature is climbing rapidly, now passing 90 centigrade. And there's little bits of smoke starting to appear from various parts of the cable. Of course, it's not surprising, as it's not rated for this kind of temperature. So current still around 20 amps, and temperature is now exceeding 120. And there's plenty of smoke now appearing from various parts of the cable. Now, of course, this isn't what the current would have in normal operation, but again, we've got those three in parallel, so this isn't exactly a normal arrangement anyway. But nevertheless, we're going to be destroying this cable because it's caused far too much bother and annoyance already. And plenty of smoke now pouring off as the temperature reaches 160 centigrade, and the temperature continues to increase. Now we're just approaching 180, and plenty of smoke now pouring off all parts of the cable, and just sort of billowing around there and obscuring the display. Now this is actually outside, and I say the ambient temperature is around 10, so there's quite a bit of wind there, so this is really the best possible circumstances for this. But of course, with this kind of current, it's going to overheat no matter what. And temperature now going up to just under 200 centigrade, and I think we'll just turn up the current a bit more as well, just because we can. So just increasing it there past 24, coming up to 25 amps there. And I see now plenty of smoke pouring out of everywhere, and completely filling the entire area. Now I'll just turn off the power there, because I think we've done enough destruction on this particular item. So in conclusion then, while the smoke clears away and the temperature slowly returns back to normal, this particular flex did deal with the current moderately well, although bearing in mind we've got three in parallel there, so in reality it would have fared worse if we'd actually managed to connect it properly. But the weak points in this were the connectors on either end, that thing with the earth pin not being connected at all, and the other two failed basically straight away as soon as any kind of current was put through. And say the switch on current was in the 2 amp range, and that apparently caused some kind of failure inside pretty much instantly. And the thing on the other end, the actual part with the holes there, seemed impossible to get any kind of reliable connection to that, and nevertheless had to actually cut it off, and even then it still didn't work properly. So the connectors on the end being the weakest point in this, the flex itself probably would have managed a few amps without too much damage, but that's of course assuming you could actually get the thing to work in the first place, which seemed incredibly unlikely. But anyway, it ended up being destroyed, of course, and that was the real point. And until next time, thanks for watching.